Hello, so we're back, and this time we have a nice laptop to repair. Asus NVIDIA Graphics Intel i5. Now this laptop is coming from a computer shop. Let's check the email. So the computer shop is saying Asus customer said the charger wasn't always charging. She hit the charger and after that it became dead. Checked with a new charger, 19 volts inside of the motherboard, DC jack, but I can't track further. Cheers, sorry. So this is a weird story. I mean, the customer hit the charger and the laptop stopped charging. Kind of strange. I will say let's open this laptop and have a look inside. I mean, there is no way to be a connection between like hitting the charger and actually the laptop stop working. The computer shop said they tested a new charger and yeah, it's not working. So is something wrong with the laptop? And the laptop is open. This fell down. Okay, let's try to plug a charger and see what's going on this motherboard. So we need a Asus plug. I mean, Asus, Toshiba, they are the same, right? Yeah. Yeah, this one. Perfect. I mean, this is a classic charging port. Nothing can go wrong with this charging port. 19 volts, plug in the charger, and it's taking up power. Nothing. Zero. Nothing. Okay, so what we are checking first? Well, in this case, I will say let's check first if we have voltage on the charging port. The computer shop said it is power here, but let's be sure. And it is. We have 19.5, you can see. So the power, it is reaching the motherboard. Now here we have few inductors. I can see them from here. The voltage after the inductors, 19.5. So what we are checking next? Next, we are trying to figure it out where is the first and the second MOSFET of the circuit, because the power from here is going to the first and the second MOSFET, yeah? Is going to the first MOSFET. Then the power is coming out from the first MOSFET and is going to the second one. Then it's coming out from the second one, and from there you have your main power rail, which most likely is not present, but we can check that. So main power rail, 0, 0. Let me check on a different place, like here. Main power rail 0, 0. So the main power rail is not present. I will say, let's unplug the battery. Now let's check the main power rail to ground, yeah? Because that can be a reason why the main power rail is not present. So main power rail, not shorted, huh? No, it's not short, you can see. So the main power rail is not shorted to ground. And also, let's keep an eye for a BQ chip. I can't see any BQ chip here. No. What is this? I mean, okay, this is Wi-Fi, but what is this? This is actually the hard drive, huh? It looks like a Wi-Fi card, probably because it's on disk. So must be the SSD. And we have our EC chip there. Huh. Interesting. I mean, they don't even bother to use two screws like here. We have one. You see, you can't put screw. Even if you want to put a screw, you can't. Here is missing. Here is missing. Dodgy manufacturer. Okay, you know what? Because I can't see the first MOSFET here on this side of the board, I can't see the BQ chip on this side of the board. I'm assuming we have to take the board out. And the motherboard, it's out. Kind of. Yeah, it's out. We still have the keyboard connector here. Yeah. Yeah, that's a cool motherboard. I can't see liquid damage. I can see the power. We have the power button here, so we can test that. Good. Let me leave this on one side. Now, can you spot any problem on this motherboard? So let's figure it out. Where is my first. Check here, yeah? You have charging port. Yeah, then you have first MOSFET, second MOSFET, you have the current sensor, then this, it's your main power rail. So our problem is here. Let me plug the charger. Plugging the charger and the board is coming on. That's crazy. Check here, the board it's on, it's taking like 700 milliamps. What is that? The board got scared, right? Yeah, probably. My little friend is next to the board. How this is possible? The main power rail was missing. We checked together. One more time. It's working. You think it's not working anymore? Wait. Huh? It is working. Power button. Yeah, it's going off. Pressing the power button is coming on. Okay. So must be something which is connected to the motherboard, right? Otherwise, how you will explain a fault like this? So what can be wrong? The other USB can be. You remember we made a video about shorted USB. Can be the screen, can be the keyboard, can be. Let's plug the keyboard first. And looks like it's working. All what is left is the screen. So what do you think about the screen? Let's plug the screen. But we checked and was no short on the main power rail. Plug in the charger and it's working. That's crazy. Yeah, probably we have picture. Check there, we have picture. You can see and it's loading the windows. So what is faulty? I can't give the laptop back saying I fixed it. Then actually I didn't do anything. You think actually it was a frozen BIOS? Let me plug the battery. Actually the battery is the last thing which has to be plugged. You think it can be the battery? Plug in the battery. Plug in the charger. No, it's working. Yeah, the laptop is coming on 900 milliamps. Why the battery is not charging? This can be interesting. Definitely can be interesting. No, I'm sorry, I put the board back. The voltage on the battery is like 0 volts. Okay. Let's take the power supply, lowering the voltage. Plus on the battery. Let me lower the current. Current goes down, good. Plus on the battery, and it's taking like 10 milliamps. We have 3 cells. Yeah. Okay. The battery is not charging. No, nothing. No matter what, I cannot charge the battery. So the charger is plugged in, but it's not taking any current, and the battery voltage right now is like 12.5. I'm plugging the charger, and the battery voltage is 1.5 and is going down. Check that. But the fact actually we have voltage on the battery means the battery is still speaking with the EC chip. Now I found something interesting meanwhile, because I was thinking, okay, so the laptop was not working. It was probably a corrupted EC firmware. But why a corrupted EC firmware? Now let's check together the BIOS battery. So the BIOS battery voltage is, check there, Check that, check on the screen. 0.7 volts. Now you have to understand, the BIOS battery, it will only, the voltage from the BIOS, the current from the BIOS battery, it will be used only if the battery is dead, basically it's over discharged or faulty, like in this case, and the charger unplugged. When the charger is unplugged, the battery is obviously faulty, then the BIOS battery will provide power to the EC chip and it will hold the EC firmware inside of the EC chip. But there is like, you have the battery level, okay, and it's going down, 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 down. And there is kind of a level where between, holding the memory and not holding the memory. There is a thin line where actually the information is getting corrupted because of the low voltage. And that's what happened on this laptop. 0.7 volts on the BIOS battery. Let's replace the BIOS battery. That's the first thing what we have to do. I do have actually it's the same connector. I can't believe. And we have another BIOS battery. Plus, minus, yeah. We have another BIOS battery here. And this BIOS battery has, let's check, 2.9 volts. So now we have a good BIOS battery. And now the laptop, it will work. We can send it back and it will not get corrupted again, the EC firmware. So we repair the BIOS. Now the next in line is to repair the battery. And the battery is kind of partial faulty because we have voltage on the battery. That means the battery speaking with the AC chip and is saying, you have to charge me with that current. And the AC chip is speaking with the power management chip. And the power management chip is providing current to the battery. This is the power supply for which is charging the battery. So that's how the laptop knows how to charge the battery with certain current. So we know the battery is still speaking with the AC chip. Means the battery is not locked, but still it's not working, it's not taking power. What I think is the problem, I believe either it's a firmware error inside of the battery or even a burn fuse. Yeah, looks like this is the genuine battery. Good. I will get an LBA device and we're gonna try to fix this battery quickly. Good. So what do we have here? We have the LBA interface, we have the wires, and we need only one ground. No, sorry, that's plus. So one plus, we need one minus. And then we have data and clock. And white. Perfect. So we have all wires here. Let's try to read the battery. Let me bring the software on screen. NLBA. Good. Let me bring it on top of the multimeter. Perfect. Great, fantastic. Now let's connect. Connecting. Good. And we press start reading. And it's not reading. Because the battery is dead, let's try to push the voltage to the power management chip from inside of the battery. And start reading. And we are reading the battery. That's fantastic. Let me press stop, read all at once. So that's the BQ chip we have inside. design capacity, cycle count 164. You know what? This is not a old battery. Capacity, the battery is like new. Check the capacity of the battery. It's exactly like new. Compute health. No, 1 second. The capacity, it's actually. Wait, 1 second. 1 second. 1 second. So the health of the battery is basically the health of the battery, and this is like nearly new. But the charge state, yeah, the capacity is telling me it was saying full. It was saying like 100%, and now it's 0. It is possible this BQ power management chip to have an error inside of it. Because check here now, read capacity and it's telling me like it's empty, but it was like 100%. So the battery is locked. You can see here on the bottom, locked. The cells, look, the cells are over discharged. I mean, we have like one cell with 1 volt, like proper discharged. Okay. It's not looking bad. I mean, all cells, they have nearly the same voltage. That's not a problem. The battery is locked because the cells are very low. So how we can fix that? You know what? The battery is locked because the cells are over discharged, which is kind of stupid. You know what I mean? I mean, okay, I just want them to charge, so the battery will get unlocked. So what I'm gonna do, I'm gonna charge the cells, but all 3 on the same time. Now, this software is beautiful. You know, I'm a supporter of the NLB device, which is the only one which can, you can unlock and diagnose the batteries. It's not even point trying power off to charge the battery because the battery is locked and it will not charge. Charging tab is selected and nothing. Charging the battery and no battery communication, obviously, because the battery does not have voltage, not even to hold alive the BQ chip. So if I can hold the device like that and I can try to push some current into the cells. But how? That's the question. Let me make this smaller for a second. Yeah. So let's do an incision here. Yeah. Surgical incision. Good. Let's see what we can see here. We have access to, and we have access inside of the battery. So check that. Just beautiful. Now let's check the voltage. We need the voltage of the whole 3 cells here. We need like 3 volts. 2 volts, 3 volts. Here and here, you can see on this, you can't see on the screen. Okay, so here and here we have 3 volts. So what I'm gonna do with the plus on this side, yeah, here. So I will come with current, yeah, and check on the voltage. Check on the screen on the voltage. Check on the voltage. 3 volts per cell. Hopefully you can see. The battery is still locked. We have a poor balance. The voltage is going up. We have like 3.3 per cell. But it will come close, the balance. Yeah, I know it's poor balance, but it will get better. Now I'm coming with the powers, but you can't see. I'm pushing 3 amps. Yeah, we have 10.3 volts. And obviously the cells are on the serial mode, so I'm applying current at the ends of the cells, yeah, being on serial mode. So I'm not charging one cell, I'm charging the all 3 cells on the same time. Now the voltage is like 3.4, the battery is still locked. You think the fuse is blown? I mean, with 3.3 and poor balance, the battery should be unlocked, even with poor balance. With bad balance, yeah, it'll be locked, but with poor balance, should be fine. Yeah, the balance does not issue. The battery will get balanced itself when you charge the battery. Okay, I think I will stop now because the battery is still locked. Let's have a look at the fuse. Yeah, obviously the voltage is going down because we pushed a lot of current. There's something smoking on this battery. Lol, what is here? That's crazy. Check it. The battery is smoking. Not sure if you can see. You know what is smoking? Actually, the fuse is smoking. Still reading, still. Check that. You can see smoke. And look, the solder is melted. Check that. But why is that? So the fuse is not burned. I'm confused. Because we are pushing current. Let me power off. The fuse is still good. No, the fuse is still good. This is a heated fuse. That's how it's called. So the fuse has a heater, and when you apply current from the cells, then the heater is getting hot and is melting the solder bridge. That's how this fuse is working. But let me try because it's interesting. So if I'm pushing current into the battery, no, now it's not getting hot. So why the fuse was getting hot before? No, the fuse is good. I think it's good. Let me check. So the fuse has to have 0 ohms and has 0 ohms. Okay, the fuse is good, it's not burned. Our problem, it's actually right now, yeah? Right now our problem is the battery is locked. But why? Give me 1 second. It's because we have an enable pin here. No. No, all are ground. We don't have an enable pin, no. Okay, let's go to, yeah, we can see here it's locked. Let's go to reset, new reset. Good. Next. Next. Yeah, so check that. You can see the PF status here. That's mean the flag status, and we have a bunch of errors inside of the EEPROM. Yeah, because this BQ has a EEPROM. So the solution is unseal the battery. Good. Read chip info. Okay, we still have the errors there. You can see them there. Now I will press clear chip errors. Errors cleared. Then read chip info and check now. Check now. Yeah, 000. You can see. So all errors are cleared. Then we can seal and exit boot. Yeah, all good. Now everything is fine. Now end reset. Let's try one more time and check here. Yeah, the battery is unlocked. So we just repaired this battery. Now I can go on the charge tab. I can press start charging. And check here the current. Check the current. The current is going up. So the battery is start getting charged or getting current. But you seen what was interesting? I mean, I'm lucky. I got this in a video. So you seen that heater on that fuse? That's because of a firmware error. because obviously the BQ chip is controlling the heated fuse. Now I was, I was surprised. I said, maybe the fuse is getting hot because I'm pushing current from the NLBA. But this is pushing like just a low amount of voltage, just enough for the BQ chip in order to work, not more than that, and not that much current. So no, what we seen there, the heater from the fuse, getting the solder melted, it's a BQ chip firmware error. So the firmware was corrupted. I mean, this is crazy. We had corrupted firmware inside of the EC chip from the laptop. Then we have corrupted firmware inside of the battery, but has no connection one with the other. Like no connection at all. So check here. The charging current right now is 1.9 amps. You can see it. The cells are start getting balanced. Still, this is a little bit ahead. If I press stop, battery info, read all, and yeah, you can see the balance is getting corrected. If I leave this like 10 more minutes on charge, I will have good balance. Let's wait 10 minutes. Okay, I left the battery like 10 minutes on charge. We can see now the cell balance, they are balanced. So everything is fine. The capacity, the battery is still empty. The health is same like before, 164 cycles. This battery is like new. So what I'm gonna do now, let's switch. Actually, I'm on desk. Yeah, that's fine. I will disconnect the battery because everything is fine. Yeah, everything is fine now. Let's put the battery back into the laptop and let's test. Yeah, let me let this on one side. We don't need it. Let me bring the laptop. Good. So we are plugging the battery. So the battery is plugged, yeah? Let me plug the charger. Plug in the charger. Yeah, just follow the current. Let's see if it's charging. Check that, 2.4 amps. I believe the laptop is coming on because we reset the BIOS, yeah? We disconnect the old battery, we connected this one. Yeah, it's on. Let me shut it down. 1 second. Let me shut down the laptop. It is down. Check there. 1.4 amps. So the battery is charging fine. If it's holding the charge, of course it's holding the charge. This battery is like new. If I power up the laptop, check here, yeah? Power up. And I will unplug the charger quickly. So the laptop is on, loading the Windows, unplugging, check here, yeah? I have the charger here. And it's working fine. Plugging back the charger and start charging, loading the Windows. So what do you think about that? Beautiful repair, easy pizza, not that easy. It took me a while, this repair. Anyway, I will leave a link on the description, yeah, from where you can buy the NLBA analyzer. And I will be honest with you, yeah. From where I got the device and I'm fixing batteries, I found none like to say, oh, I have a battery with the cells, they have no capacity. No, I didn't. All batteries, they have errors, they are locked from different reason, but not a single battery to be like with used cells. I mean, we can replace the cells and, reset the cycle count to the device. We can do it, but I didn't found something like that. All batteries, they are like on this case. So the battery is like new, capacity-wise, yeah, it's like new, but it's locked from a different reason. And I believe here, what happened here was that big firmware error, which activate the heater and actually discharge the cells. Because soon as I charge the cells, that heater came on and start heating. I felt the board hot, and you seen the solder was getting melted from the fuse. Luckily, it didn't burn. I mean, we could rebuild the fuse again with the solder, but yeah, it was fine. Never found this fault before. I mean, just that kind of error, like a firmware error, which it will activate the heater from the fuse. Okay, I'm happy I helped this customer. I'm gonna stop now. I will say thank you for watching. Like, subscribe if you like the video, and see you on the next one. And don't forget, you have the link on the description from where you can buy the NLBA analyzer. It's a pretty good deal. Bye.